In the previous lecture, we have observed that the CNN model that we built from scratch was not efficient as it has led to overfitting. In this lecture, we will see how we can use existing state-of-the-art CNN classifiers with transfer learning to optimize the training experience. Let's first introduce transfer learning through a simple example. There exist in the literature several CNN classifiers that were pre-trained on a very large dataset. An example of this very large dataset is the ImageNet dataset. It has 22,000 categories and 14 millions of annotated images. The ImageNet classification challenge uses 1,000 classes out of the 22,000 classes and 1.4 million images among the 14 million total images. Several state-of-the-art algorithms were trained on this dataset. So initially, the CNN will start with randomly initialized model, then trained on the ImageNet dataset. This will result on a pre-trained CNN that is able to classify 1,000 classes. This means the newly trained network has weights that makes it able to recognize the features of 1,000 categories. The idea behind transfer learning consists in reusing this pre-trained network with a completely new dataset as a starting point, instead of using a new network with random initialized weights. The reason behind using transfer learning is that the custom dataset may already contain objects with the same classes that the pre-trained network already able to extract their features. Thus, the custom new dataset will be trained using the pre-trained weights and will fine-tune itself during the new training based on the new dataset to generate a new network. This process leads to much faster convergence time of the training algorithm, in addition to increasing accuracy because it leverages the initial knowledge that the pre-trained network already has. This is a summary of the concept of transfer learning. It is simple to do transfer learning in TensorFlow and Keras, and we will show this in details in the next couple of slides.